In section 11.2, another part of a circle that you would need to know is a chord. C-H-O-R-D, not chord, but chord. A chord is a segment whose endpoints are on the circle. So you'll see that red segment there, that is a chord. What would be the longest chord of a circle? Well, the longest chord of a circle would actually be the diameter, because the diameter is a segment whose endpoints are on the circle and it goes through the center of the circle. So the diameter is actually the longest chord of the circle. Now, let's talk about what happens when you do have the diameter and it's actually perpendicular to something. So let's say that you have a diameter or a radius that's perpendicular to a chord. So if you look at this picture here, we have a diameter and it is perpendicular to the chord. You say, how do we know it's perpendicular? Well, it's forming a right angle, and that's what perpendicular lines form. So because of that diameter, it bisects the chord and it bisects the major and minor arcs. Basically, this diameter cuts the whole circle in half. So whatever's on the top is the same as whatever's on the bottom. So the two segments on the chord that are marked in the red, those are congruent. The two arcs over here marked in blue, those are congruent. And then the two arcs marked in green, those are congruent. When you have congruent chords, they are equidistant to the center of the circle. Think about that word equidistant. It sounds like equal distance, which is exactly what that means. So if you know that AB is equal to CD, they have the same length, then the distance from AB to the center is the same as the distance from CD to the center. So these two segments in red, they would have to be congruent to each other. Now notice that it's forming that right angle to the chord. That's important. That right angle needs to be there. So as we look at page 593, start with 3, 4, and 5. They're pretty basic. Just look at those problems and look at the answers I've given you here. I want you to see if that makes sense. And then take a look at number 12. With number 12, what you want to do is we're going to swing around that X segment to form a right triangle. So basically, we're going to take that X, that segment that's X, and just move it so that you can connect and form a right triangle. What happens is the legs would then be 3.6 and 4, and it's 4 because 4 is half of 8. And then we could use the Pythagorean theorem. We could take 3.6 squared plus 4 squared equals x squared. And using our calculator, when we solve, we would get an x value of 5.4. Okay, so this homework is page 593. You see the numbers that are listed there. This homework is going to be due on probably Thursday, which is April 16th. I'll update that if we make a change.